Who can tell me what this is? Yes, sir. I don't know. What is it, someone? Is that right? Negative radical 2 over 2 it is. Now, this one was interesting. Before I wrote that up there, this one was interesting because 9 pi over 4 isn't on the unit circle, so you couldn't just flip back over, which is why I made this one the dom. What do you have to do with this one before you can even work with it? You have to find a coterminal angle with it. You have to add 2 pi. When you add 2 pi, then you would get negative pi over 4, which you could then add 2 pi again and get 7 pi over 4. Or you could just find negative pi over 4 in your unit circle using the techniques we went over yesterday. And yes, it was negative radical 2 over 2. Very good. Questions about that? Yes, ma'am. Okay. Now, yesterday we started with SOHCAHTOA. You don't actually need SOHCAHTOA for anything that we're going to do yesterday or today, but you're going to need it like crazy tomorrow, so that's why we entered into it. But you don't actually have to use it for anything in this particular section. All right. We good? Here's what we started with yesterday, when I was really flustered with nothing working and everything. So I thought we'd start with it again today since I didn't make you do anything with it yesterday. Someone read the directions and tell me what you believe the key thing in the directions is. There's a key 2-word expression, which is going to unit circle. What do we know about the radius of the unit circle? 1. The reason you don't need Pythagorean theorem to, I take that back, you are going to need SOHCAHTOA, but the reason you don't need Pythagorean theorem to solve this is because your triangle, which I will now draw here, it tells you every piece. The unit circle tells us the hypotenuse is what? 1. The x-coordinate lets us know the horizontal component, negative 15 over 17. The y-coordinate lets us know the vertical component, 8 over 17. And because on the unit circle your hypotenuse is 1, your sine, cosine, cosecant, and secant will all just be one of these two things because you're dividing by 1. So, sine of theta, 8 over 17 over 1, opposite over hypotenuse. So, sine of theta would just be 8 over 17. What would cosine of theta be? Negative 15 over 17. Very good. Remember, it's sine is opposite over hypotenuse. I left it written up there. Cosine is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So that's 8 over 17 over negative 15 over 17. How do you divide fractions? Flip the second one and multiply. Cancel, cancel. And tangent is merely negative 8 over 15. So now all I need is cosecant, secant, and cotangent. Who wants to raise your hand and tell me what those three would be? Sarah. Very good. Muy bien. Just flip the first three. Cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. Yes. Because it's on the unit circle, you don't even have to do Pythagorean theorem to find your hypotenuse. Now, if you did, you should find that it's 1, but unit circle, yay, you know what hypotenuse is. Questions on that one? Good. In that case, you guys try this one. Try that one. I need to know the 6 trig functions of the angle. And if someone's feeling confident, they can work it on my board. Who wants to work it on my board? Anybody? Jack, you want to do it on the board? Dylan? Board? Dylan? Yeah. Bridget? Work it on the board? No. Chris? No one's going to step up to the plate here? Alright. Alright, sir. Go for it.
Oh, it's probably going to be wrong. So we got How do you move this thing? Oh, there it is. Oh goodness gracious, how do you run this thing? Yeah. How did he run so fast with this thing? Like he's a boss. Oh, that's a horrible thing. You're right. How do you erase? I don't care. Oh, how do you use this? CSC. That's no. This is SEC. Well, that's a negative, if you can see it. Yeah. It's the same thing, but it's going to be... I'm just going to skip a step. Oh. Code. Oh, Jesus. Out in the world, I'm trying to remember. Hold on. Trying to remember. Hold on. I had this. No, it's not.
Are you better?
Yeah, I can't remember code that.
He's pretty much no mark. I'll do a little reduction for you, but that's okay. Okay.
Oh yeah, that's
right. All right. The only thing that this is missing, tangent reduces to -1 because it's the same thing divided by the same thing with one of them being a negative. The 2's cancel here, leaving you with just negative radical 2. The 2's cancel here, leaving you with positive radical 2. And what's the flip of -1? -1 would be your cotangent as well. So, I won't. Hold on. Yes. Hold on a second. I can. But I have to take a picture of it first. You want to see what happens if I don't take a picture of it first? Oh, because what it's going to do is it's going to blow up every single streak of the pen, and it's no longer going to be connected. Isn't that kind of nifty, Noodle? So, and I kind of freaked out the computer by doing that. Oh, darn it. Aww. It's like, why did you make me do that? Oh, okay. Undo. Please undo. It's so mad at me. I asked it to magnify like 1,000 things at once. I'm joking. Undo. Oh. Aha! But it's so mad at me, it's going to leave the equal signs the way they were. Okay, so anyway, blowing it up, if I just take a picture of it and blow the picture up, here you go. There you go, there it is, blowed up. It is hard. Let me get rid of all this. Oh no, wrong shape. Okay, questions about how to do coordinates on the unit circle. Also, I need these three people who did not listen to instructions yesterday. 3636, 0165, 9641, and 1471. You weren't supposed to hand these in yesterday. You need to come pick these up. Oh, no. I'm sorry. I didn't mean to do that. Excuse me? Sorry. Yes, ma'am? No, because this, okay, first of all, -1 by itself is over 1, so it'd be -1 over 1, and you flip that. But really, even more fundamental than that is you could have just flipped this fraction, which still would have been the same thing. You're thinking if it was like on one of those 4 quadrantal angles, which is what you call them when they're like right on the line. Excuse me. Sorry. Sarah, do you have a question? Okay. Moving on. Click. Now, this is what we did yesterday. Did we have a tangent one yesterday? Okay. Were there questions on how to do this? I think we did this one on the board actually yesterday, didn't we? Yeah, so I'm just going to keep going. Okay, now, the new stuff. This is actually interesting. This is pretty much identically what you just did, except it didn't give you a picture, and it didn't tell you that it was on the unit circle. Now, if it doesn't tell you it's on the unit circle, then you technically have to use other means to find out the pieces of your triangle. So, let's look at this. If they ever, and they will, I don't know who they is, but if the book ever just randomly gives you trig functions, this is what I teach everyone whom I've ever taught trig to. If it ever just randomly gives you trig functions, then they have to apply to a triangle. So draw yourself a triangle with random angle theta. This came from my brain. Okay, that's not like a standard template. It doesn't matter how you draw it. It doesn't have to be to scale. They give you a trig ratio, just draw a triangle with a theta. Right triangle with a theta. Now, what is sine of theta? Like opposite, adjacent, what is it? Opposite over hypotenuse. Opposite over hypotenuse. And you can use the trig functions to fill in the pieces of your triangle. What does cosine stand for? Adjacent over hypotenuse. Now, bam! We've got our triangle, and you can find the rest of your trig ratios. What would tangent of this angle... Actually, I shouldn't have called it theta. They gave me an angle. What would tangent of t be? 8 over 15. And then for the other three, you just flip them all. If they give you trig ratios, draw your own triangle. Use the ratio to figure out what pieces go where. Try 27. I just want everybody to see if they can draw the correct triangle for 27. I don't care what it looks like. Just it needs to have a right angle and it needs to have a theta. Or in this case, a t. Not a theta, but a t. So, try to draw a triangle that would correspond with number 27. Ooh. What? And then we'll find the 6 trig functions, which is what it actually asks us to do.
So we need FCCLA and FDLA to meet in the end.
Hey, long time no see. Let me pause this. Don't draw it yet. Okay, that's the gist I'm getting from the class. Don't draw it. Oh, okay. You want to draw it, Latifah? Well, come here. You can work this whole problem. You can use this portion of the board down here. I've only been using that thing for 2 years. The first 3 years when I was upstairs in this building, I had an actual board, and I could just write on it like that, except it was my.
How do I get the triangle?
Well, you can just draw your triangle, or you can hook in my little handy-dandy shapes thing. You know?
I really can't see this. Oh, I see it.
No. Yep. There you go. Now just click and drag anywhere on the screen. Bam. All right. Now go back to your pen. and do your voodoo. If you do. Where's your theta? Where's your T? Okay.
Give me time.
Alright, now your triangle may look a little different than hers, but this is right. From her T, you want to go do your trig ratios? Over here on the right. From her T, her opposite is 1, her hypotenuse is 3. From her T, her adjacent is 2 radical 2, hypotenuse is 3. Now all she's got to do is actually list the trig. Of course, you don't have to do sine and cosine since they're given. You can start with the tangent and the other 3. Hit the eraser button. Very good. Yes.
Isn't 1 over
Well, you already heard that one.
Is that right?
What?
Is that right?
Actually, yes. Yes, that's what I got.
Oh, okay. Is the opposite
There's unit over
side
4 right there. I think you may have had 2. That one. Tangent. Because this will be 2 times this 2. So that's the 4 and then the radical 2. Just flip this and count. Well, that'll work too.
Flip what one?
Here, give yourself more space. Hit the arrow. Number 2.
Mhm. Oh, I knew that.
A quick way. Very good. Way to go. Very, very good. Any questions about what you see on the board? This is all correct. Anybody? No questions? No. All right, now, here's the thing. Oh, we already did 41. 39 and 41 are pretty much very similar. We already did 41, so 39 shouldn't be that hard. If we added 2 pi on 41, what do you think we have to do on 39? Subtract 2 pi. Very good. And what is 2 pi in terms of fourths? 8 pi over 4. Very good. So that'll just be cosine pi over 4, which you can get straight off your unit circle. Tangent of 5 pi over 4, that is straight from the unit circle. Like you don't even have to do anything to it. Cotangent of negative 5 pi over 4. Oh, this one's a fun one. Alright, to do cotangent of negative 5 pi over 4, first find 5 pi over 4. Okay, so that would be about 225. Flip over the x-axis. That's how you do the negative angle. Now, what would tangent of that angle be? Who can tell me? You're right. Remember, 5 pi over 4 is at 225. Over the x-axis for the negative angle will take you to 135. At 135, tangent would be sine over cosine, would be positive radical 2 over 2 over negative radical 2 over 2, which reduced to negative 1. Then you have to flip that for cotangent, which would still be negative 1. Now, 47 through 51 are funny because they look hard, but actually they're very, very simple, especially 49 and 51. What did we do for these two? What did we have to do? We had to add or subtract 2 pi, right? And what we got back to the exact same angle, didn't we? So if you added, say you have some angle, you had 2 pi, right back where you started, 4 pi, 6 pi, 8 pi, and they're all going to be the exact same thing, right? Anytime you add or subtract an even number of pi, 2 pi, 4 pi, 6 pi, etc., then you're going to end up with the exact same angle. So actually, whether this said minus 2 pi, minus 4 pi, minus 6 pi, minus 1,000 pi, this piece right here doesn't change your angle at all. So actually, this is all you would have to do, that part right there. These are pointless because it's just going to take you right back to the same angle. So this whole thing is just sine of negative pi over 4. What's that, square root of 3 over 2? Someone want to verify that for me? No, negative pi over 2. That's what this pi is. Very good. Negative radical 2 over 2. So, if you ever see plus or minus an even number of pi, even if it goes up to a trillion, it doesn't matter. It's not going to change your angle. Now this one, actually, before we look at that one, think about it. If an even number of pi takes you all the way around, what do you think an odd number of pi does? It takes you halfway, exactly. So, anytime you add an odd number of pi, go to the actual angle, so pi over 4, which would be at 45 in unit circle, and an odd number of pi takes you directly across the origin. So what's directly opposite of 45 in a unit circle? Yeah, 225 or 5 pi over 4. So now take sine, tangent of 5 pi over 4, and what would it be? 1, and then make it negative. So negative 1. Let's do a few more of those. Let's do a few more. I'm going to give you 2 examples, and then I'll call on somebody at random to give me the answer, not just volunteers. So everyone needs to do it. Let's see. How about, well, I'll even go crazy. I'll give you reciprocal functions. Secant, negative secant of negative 3 pi over 2 plus
He's making great now, named Pasta and criminal justice.
and then I also want positive cotangent. That's right. Positive cotangent of, let's see, Wait, you didn't do 60. 3 minus 7. Those are the two things I want. And yes, if you're wondering, the numbers are so big, you emphasize a little bit more. Which one is even? Quadrillion and 4. So, what was it? Does the quadrillion and 4 change anything? No. So all you should be doing is negative secant, negative 3 pi over 2. So, you should be thinking unit circle, 3 pi over 2. Where's 3 pi over 2 in the unit circle, Lazarus? At the bottom. So what does a negative angle do? Where does it flip you? Over the x-axis. So it'll take you to positive. So negative secant. What's secant the flip of? Cosine. What's cosine of positive pi over 2? 0. So negative 0, which would still be 0. The whole thing was 0. It was not a waste. Well, it wasn't. Now, is this odd or even? Odd. So you need to find this angle and flip over the origin, go directly opposite. What is opposite of pi over 3? 4 pi over 3. Very good. So, we need cotangent of 4 pi over 3. Whoa. I was going to say let's start with tangent. Tangent would be your sine of your cosine. What is sine 4 pi over 3? Negative radical 3 over 2. I'm going to pre-flip this. What is cosine of 4 pi thirds? Very good. Now for cotangent, you need to flip it, which I've already done for you. Sine, cosine, but for cotangent is the flip of tangent. So you just flip them, ending up here. Now all you got to do is flip the bottom one and multiply. Because it's 4 pi thirds. Because it's an odd number of pi, it's 4 pi thirds, which is going to put you in the third quadrant. Times 2's are going to cancel. The negatives are going to cancel. So actually it will end up being positive. Justin, I don't know if that's what you were referring to. So positive 1 over radical 3, which would turn out to be radical 3 over 3 when you rationalize it. Very good. Very, very good. If this is hard, I mean, okay, I know I'm throwing big numbers and lots of radians at you, which is a little mean, but if you're still sitting there thinking, where in the crazy are they getting these numbers? Just look at your unit bloody circle. Your unit circle has every answer. Because, okay, pi over 3 is 45 degrees in a unit circle, right? It is here, correct? Now, by adding an odd number of pi, that basically takes it 1/2 revolution, which takes you to here, 4 pi thirds. And at 4 pi thirds, here is sine, here is cosine, and that's why they're negative. All right? Only have one slide left. Questions over that? Okay. Last one. Ooh, it's actually the same exact thing we already did. The only difference is you have to subtract and stuff. Actually, before we solve any of this, somebody tell me this. Eeny, meeny, miny, okay. What's the difference between these two numbers? Yeah, I mean, like, if you were to subtract, that's the difference, but I meant, like, mathematical difference. Which basically, you can just subtract the numerators, right? What's the difference between those two numbers? 40, pi, right? So the difference between these two numbers is 40 pi over 4. What does that reduce to? 10 pi. Is that an even number?
Yes. No,
What did we? Yes. 10 pi, even number. Yay. So what did we just say? If you add or subtract an even number of pi, does it change anything? No. All you have to do on these is subtract. If it's an even number of pi, then it'll be the exact same as the previous answer. Which I bet these will all end up being even. What's the difference? 8 pi over 4? 2 pi? No difference. What's the difference? 8 pi over 2? 4 pi? No difference. What's the difference here? 16 pi. Is that an even number? No difference. So all of these should be the exact same. And I'm not telling you that so you can just immediately mark them down. I want you to really grasp that concept. Because on your test, just to see if you've got that, I may make a test question. Hey, what is cosecant of 8 billion pi? And somebody's going to be like, oh, 8 billion pi thirds. And now someone's going to be like, oh, crap, how on earth? I'm going to have to subtract 2 pi like a gajillion times. But really, all you have to do is think of like pi thirds and think, is there an even number diff? Just subtract. And if it's an even, it'll be the exact same thing as just a simple little thing on a unit circle, pi over 3. So that's the big concept here. Even number of pi doesn't change your angle. Any questions about how you're going to find those? The part A's are all straight from the unit circle, and all the part B's kind of just gave you the answers to. Yes, ma'am.
Okay, so I know what you're saying, but what do you add?
Good question. 57. Tangent of pi. Here's pi. Tangent, sine over cosine, right? Sine over cosine. So that would be 0. We just discussed that 17 pi is the exact same thing as 1 pi, since they're an even number. So if this one equals 0, which is what you need to write, then this one equals 0. And that's what you write. Just A equals 0, B equals 0. Okay. Questions? Email. There you go. Now, you should have done 4 through something yesterday. Add this to yesterday's assignment. 6 through 24. So really all you have to do are 2, 4, and then 26, 28, and then the bottom part. Add this to yesterday's assignment.